As of right now, we are recording, which means we will be able to put this up for anyone that was not able to join us tonight. So without further ado, I can say welcome everyone. This is the 7th in our Tuesday evening webinar series. It is my great pleasure to welcome tonight Dr. Valentina Parma from Temple University. Valentina is she is a psychologist, and she is working with people who have smell disorders. Sorry, I've got my papers shuffled now on top of everything else. So thank you, Valentina, for joining us. And I also have Professor Thomas Hummel, who, as many of you know, he is very much at the forefront of research for people with smell disorders. And I met Thomas in 2014, and I've been very fortunate to be able to attend some of his courses on smell dysfunction and human olfaction. So it is really a pleasure to have both of you with me today. Right, so I think, and as always, we have Aidan Kirkwood, who is managing the chat bar and is basically in the background fanning me and just telling me not to worry. So thank you, Aidan, for doing all that just before we started. So Thomas, I think I'd like to start with you. I'd like to start with a clinician's overview. Maybe you could tell us a little bit about what you've been seeing in your clinics, what you think about COVID-19 related smell loss, and just, you know, how have things changed for you in the last sort of 6 months? So off you go.
So actually I brought a few slides, so which I like give a general overview about affected loss. If I may show that, maybe?
Yes.
Yes, you can see my screen?
Yes.
Very good. So what I brought here is like a little overview about affected loss. So you have the affected system. There's a video of the nasal cavity that you know where we are. Like a look into the nasal cavity. You have the hairs on the outside. And here on the inside, on the septal side, you have this little pouch here. It's the nasal pouch. It's non-functional in humans. You have the lower turbinate. It works a little bit like heating devices, those turbinates. Here's the middle turbinate. And up there in the olfactic cleft is what you see, this whitish thing, is where you can see the bone shining through the mucosa. That's the thin bone here that separates the brain from the nasal cavity. And it's covered with this mucosa. In the mucosa, you'll find the olfactory receptor neurons, so that mediate olfactive function. So in this bone here are many tiny holes in there. I think like estimates are like 40 to 60, many of those. And through those holes, actually, the olfactory nerves, they make their way into the brain. There's also some ideas that also have been since the 1930s, that actually small viruses enter the brain through these holes, and they go into the brain, up there, through the olfactory nerves. And that's also what is likely to happen in coronavirus infected people. That the coronavirus is not just acting at the level of the olfactory epithelium, but it's actually going up there into the brain through the cribriform blade. So olfactory processing is happening at the level of the olfactory epithelium. It's happening at the level of the olfactory bulb that is sitting just on top of the epithelium, and then it's processed in other parts of the brain. So this is what happens in affection. Why is affection important? I guess you know that. I just jump over that. So it's a warning system. It has social functions. It has mediates flavor perception, which is very important, because then food tastes sort of sad and dull. It's kind of boring. Major determinants of affected loss are sex, age, environment, major things, a couple of other things like genetics and whatnot. I'm just jumping across that. How frequent is affected loss? Very. So like not just since COVID, but actually before, there are about 5% of the general population who are anosmic. They have no sense of smell. And this is largely age related. So if you look at older people, older than 80 years of age, then about half of them has no sense of smell. So in the same way, you find like 25% of the population above the age of 50, they have a decrease of olfactory function. And as we get older, even more of us lose the sense of smell. This has much to do with the olfactory epithelium because we lose olfactory receptors there. Actually, some of the cells they are replaced by other cells. And this is why, as we get older, we become more prone to viral infections that produce olfactory loss. So that's the same, seems to be partly also true in coronavirus-associated olfactory loss, but actually in COVID-associated olfactory loss, there's also younger people seem to be involved. So they suffer, also younger people experience like olfactory loss. Other than that, you have like sinus nasal disease that produce olfactory loss and other causes that lead to olfactory dysfunction. Major complaints, you also know that it's like largely related to food intake. It says this wording function that people complain of. People complain of their social lives. Not so much as complain about paid employment. So again, this is highly subjective. It very much relates to the study that you look at, relates to the questions that you ask. You get a very different range of answers here. But it affects our lives in many ways, in many deep ways also. And in many people, it also leads to depression. So some of all these effects produces then depression in the very end. It certainly decreases quality of life. But one also has to say that's not in all people, but some people, actually many people, they live there without a sense of smell and they don't even bother. You know, their quality of life is not changed. They don't even notice sometimes that they have olfactory loss. So that also needs to be said here, it needs to be spelled out, that not everybody is suffering from olfactory loss. Many people do, but also many people also don't. We had a study where we had 200 people, we looked at them, all of them, they said the sense of smell is normal. When we did some measurements in them, we found that actually about 1/5 of them, like 43 of 200 people, they had basically strongly compromised olfactory function, and they didn't even bother. So that's the other side of the coin. Just wanted to mention that. Mm. Who is suffering more? It's women. So because their sense of smell is better, so they also exhibit more, they suffer more from olfactory loss if they suffer. So you have a decreased quality of life, mood is more compromised, depression is more prevalent in people, in women who suffer more. But also the depression is mild, what you also see here. One has to think about the interactions between the senses, the chemical sense especially. So smell is also not acting in isolation, but it also is working through orthonasal and retronasal channels, and it's working together with taste, so with gustatory function, sweet, sour, salty, bitter, umami, and it also interacts with trigeminal function, which mediates like burning and stinging and other sensations inside the nose and mouth. So all these senses, they interact and they come together and build what we call flavor in the very end. To that, there's also seeing and hearing that contributes to that. So what happens when people lose their sense of smell? Typically, they also lose taste a little bit, and they lose trigeminal function. And much of that has been shown in a couple of studies, much of that is probably due to the interaction between the senses, because smell is amplifying taste, and smell is amplifying trigeminal function, and vice versa. So if you lose one of these pieces of the equation, then it also affects the others. So typically what we find is that people with olfactory loss, to various reasons, to sinus nasal disease, to head trauma, they need more salt, they need more sugar to spice up their foods. So COVID associated olfactory loss, what do we find here? When you look across the literature, you find that a little bit more females than are hit by the virus, by the olfactory loss than males. Average age is between 30 and 60 years, but there's large variance in there. When you look at the COVID-associated olfactory loss, the numbers, they vary tremendously. If you look from the different studies, between 5 and 85%. It's really a peculiar finding that in China, the first studies, they said only 5% of the patients, they had olfactory loss. Which makes you wonder. I mean, partly it can be explained by cultural, that in China, people don't pay so much attention to olfactory loss, and this may explain part of this story. But can also be something genetic, maybe Chinese, they are less prone to olfactory loss to coronavirus, we don't know. But what you also can see here is that the numbers, they change, they vary a lot. Recently, there was like a meta-analysis, and that said about like 50% of the patients with coronavirus, with COVID, they also exhibit olfactory loss. But this is, the last word is not spoken in this area. About 10% is olfactory loss seems to be the main symptom. So basically this number says there are people there where olfactory loss is the main and only symptom. Today I'm also had a patient who had exactly this. She just had olfactory loss at the beginning of March, and later on she didn't even notice. She had some, she didn't have fever or anything, like a little bit muscle aches. And later on, she had olfactory loss. And later on, she, because of the corona pandemic, she had herself tested for corona antibodies, and she was positive. So actually, this olfactory loss that occurred to her all of a sudden without any other symptom, it probably was related to coronavirus. Then you also see taste and trigeminal sensitivity that are affected, but to a lesser degree. Then olfactory function is, and typically you have little or no nasal congestion. That's different to other infectious diseases of the nasal cavity. Temporary loss seems to be very frequent in patients with COVID-associated olfactory loss. So estimates are like in 80% of this population, it is gone after a couple of weeks or a couple of days. But then you have approximately 20% where it lasts longer. Again, I was saying at the beginning, the numbers are still evaluated, studies are missing to provide a large overview. So at least what we can say now, there's temporary loss in some of the patients, probably most of the patients, but in some of the patients also more permanent, where olfactory recovery may go on for years and years. This is what we now see in our clinic. The patients are calling in who have like acquired olfactory loss since the beginning of March. And since then, they have recovered a little bit, but only gradually. So we already see these patients coming into our clinic. So there seems to be also parosmia and phantasmia seems to be quite frequent in these patients. So many of these patients, they complain of smell distortions. Again, the last word is not out there. So what is the frequency of these patients who experience parosmias? We don't really know, at least when you look across the board. So where's the hope for these patients? It's plasticity of the sense of smell. The olfactory system is plastic. So you see recovery of the sense of smell at the level of the olfactory epithelium. You see to some degree at the level of the olfactory bulb. There's some argument about it, whether this is happening in humans or not. And then, of course, in brain areas, they also can adapt to smell loss, and they also can help by reconfiguring to accommodate like recovering sense of smell. With that, the last thing, what can we do to improve our sense of smell? One thing is smell training. So you can use that. If you sniff those odors every morning, every evening for a period of 6 to 9 months or even shorter, then it leads to recovery of the sense of smell. Here, that's the trajectory of people who do don't do anything. Then also in them, you see recovery of olfactory function. These are the red dots. And then people do smell training, then their recovery rates are much higher. So after 8 months, you see that people who don't do anything, about 20% of these patients improve in olfactory function. When people do smell training, it's about 40%. There are other ways to recover or to help people to recover from olfactory loss. It might also include local vitamin A and other possibilities. So, but this is like the end of my story. Okay.
Thank you. Thank you very much.
So Hilosa asked, do essential oils chosen for olfactory training influence the level of recovery? Feel the real smell versus a new smell? Or can we use oils from only one family that we can smell without distortions, excluding only floral? Only floral.
Oh, that's a good question.
Can you answer that, please?
So that's a good question. It's like basically it's important that you sniff. So that's the basis. So if you sniff regularly every day, then it's better than doing nothing. This is what we know. Also, when you change odors every 3 to 4 months, it also seems to help. So it promotes also recovery. The question is what odors you use. There's some little evidence showing that when you use mixtures, the mixtures seem to be better than single odorants, so single molecules. There's also some evidence for that. When the type of odor that you use, whether it's essential oils or it's something different, there's no study really that would support that. So naturally, you would think that, I think what's good, personally, I think what's good is like to have a trigeminal component in it so people can perceive something. Also, trigeminal activation might produce an additional activation of the chemical senses that is not brought about only by olfactory stimuli only. So a little bit of a mix could also be helpful. But this is what we know so far.
Right. And Thomas, can you explain a bit what you mean by mixtures?
Mixtures, I mean mixtures of different molecules. So one molecule would be, for instance, phenylethyl alcohol, another one would be eugenol, another one would be eucalyptol.
I
And
see.
if you, cineol, so if you mix that, if you bring that together, it might work better than the individual components.
I
So
see.
if like 4 different mixtures, it might be better than 4 individual odorants, 4 single
Right.
molecules. And the idea behind it is that you stimulate more olfactory receptors at the same time.
Good. Okay. Everyone, we will have a full question and answer section at the end, but I just wanted to make sure that anyone that had any specific questions for Thomas right now that we would ask while that's still fresh. So I think what we'll do now is we will move on to Valentina. And I should say that I met Valentina when the GCCR, the Global Consortium for Chemosensory Research, sprung to life, and she's going to tell us that story now. I have been working with the leadership team representing patient advocate, representing patients as a patient advocate. My 4 months has now of that time has now come to an end, and at the beginning of this month, I'll be handing over to Nina Hill of Fifth Sense, which is another charity to support people with smell disorders. But it's been my great pleasure, and it's been a wonderful education to work with all the wonderful people in the GCCR. So Valentina, it's now your turn. Why don't you tell us the amazing story of the GCCR?
Thank you very much, Chrissy. And, you know, it has been a pleasure for us to be working with you in this very, you know, very quick turnaround of things. Now you're gonna see my computer issues, but let's try to see if this works. Can you all see?
Yes.
All right. So today, as Chris mentioned, I'm gonna talk to you about how we came together and we formed this group of people that is now called the GCCR, which is the Global Consortium for Chemosensory Research. And basically, things started with when the patients called. And so at the beginning of March, or mid-March in particular, we started seeing on Twitter a lot of messages, and then we started like gathering together and scientists that work with human olfaction. And you can see like some of the Twitter threads at the beginning, where we were trying to understand how these reports from patients and their smell loss related to COVID were coming about. And it was quite surprising to us because usually, as Thomas very well explained, not everybody would report spontaneously about their smell loss. So usually this would come with a long time. So we were quite surprised in the beginning to see some of those reports very vocal and coming in large numbers to the chemosensory community. And so we got together one afternoon. It was on a weekend, March 21st, and the leadership team got on a call. And so as you can see, like 3 of the people of the leadership team are here, Thomas, myself, and Chrissy, and then joined with us, there are Danny Reed from the Monell Chemical Senses Center, Kathleen Ola from ULIC, Polly Joseph from the NIH, Marhaba Doyden, who used to work at Yale, and now she's working in Turkey, Steve Munger from the University of Florida, John Hayes from Penn State, Mashaniv from Israel, and of course, Thomas Umo. So this group of people started working together pretty much daily at that point in time, trying to understand how best to use science to serve this purpose of understanding chemosensation in COVID-19. And so first of all, we realized that in a pandemic, we cannot really focus only on our countries. And so we decided to embark on a global endeavor. And so we wanted to coordinate worldwide crowdsourced research. And so using the power of social media and of the internet to understand the reports of the COVID-19 chemosensory issues. And as Thomas mentioned, you have seen that the data that at that time were really very partial, like highlighted some different stories across the globe. And we wanted to have a lens on the whole world to try to answer that question. And first of all, why do we do this? Why did we decide to really, in the beginning, lost some nights of sleep and keep long days? Because we do care. And I know that scientists are not very good. Oftentimes they use technical terms and very geeky ways and dry ways of expressing their interest towards certain causes that are quite emotional, like smell loss from the patient's perspective. But we do care, and we try to use our best tools, which is science, to find some answers and some evidence that can be used and helpful in the long term. If you would like to, this is a very beautiful video that Chrissy and Aiden put together with all the members of the GCCR, and this is just a tiny fraction of all the people that have been working since March trying to understand this problem. But who are these people? Who are members of the GCCR? Well, we are currently 518, perhaps a little more since the last update, spread out in 56 countries in all 6 populated continents. So we're trying to reach really widely. And although the majority of people in the GCCR have a scientific background, there's scientists from different walks of life in a way, we also have clinicians. So we have, of course, patient advocates, and Chrissy then part of the leadership team, as she said herself. But we have journalists, the artists that provide, their art to promote the information related to the science. We have journalists that help us craft press releases and ways to reach out to the broader community at large. And so we were able, thanks to this really multi-componential effort, to reach out to to BBC, to the New York Times Magazine, to very big outlets to try to shed light not only on smell loss in relation to COVID, but generally speaking to what smell loss is. And so we're happy to have done our little bit to contribute to the idea that anosmia now is not a word that only people that either have been touched by smell loss or are studying smell loss can know, but it's more of a word that now has reached the mainstream culture. So as I mentioned before, we do care, and we want to use the scientific method to bring some evidence to answer the questions that we are all sharing at the moment. And so how do we do that? How did we decide to approach answering how chemosensory loss works in COVID-19? So we decided to put together different tools, and the first one was a survey, and now we currently have also a self-check. And a survey, and this is how the GCCR studies look like at the moment. You get on our website and you will see the, later on, you can see our website address, but you will answer just one question, and then you are directed to the survey, which is quite long in the beginning, but it helps us understand exactly what profile in smell, taste, and trigeminal function, as Thomas was mentioning before, is represented in COVID-19, and it helps us understanding also how people, whether there are different groups of patients that have been touched by COVID-19 and by other respiratory disorders. When it comes to the smell check instead, what we're trying to accomplish with that is that everybody is welcome to take that survey, and it's a monitoring tool. So we know I'm based in the US currently, and we have, as you may have seen in the news, like a surge in different states of COVID-19 again. And so if I want to check whether my sense of smell will change over time, then I can take this self-check and keep repeating it daily, weekly, or whenever I would like, to try to monitor where the state of my smell is. Of course, the more we do it, the better ideas we can have about our performance over time. Our survey, which was our first attempt to collect data, is now available in 32 languages, and we have tried to bring like the science behind this survey to many languages possible, and it has been a technical endeavor, but we managed to get the 32 languages. The self-check right now is available only in English and in German, but translations are underway in many of the other languages. So in the GCCR, we took the advantage of people that are experts in the field, of clinicians that we're seeing directly, patients, of scientists that have been studying the chemical senses for a long time, not only in humans, but also at the mechanistic level, so with animal models. So we can put together really a set of questions that was quite precise in trying to define like the different nuances of what the disorders of smell, taste, and chemesthesis or trigeminal function, so this irritation aspect of chemosensation could be. And again, we want to collect big data. The fact that we have members in 56 countries really allows us to touch and to reach many, many people. And thankfully, the use of social media has proven to be really helpful in this context, because we were able to reach many people in the span of a few days. And I will prove this to you later when I'll present to you briefly the results of our studies. The other bar that we set for ourselves as a consortium of scientists and clinicians is the fact that we want to make our science open. So what we're doing is that we're collecting this data, we analyze them so that we can be sure of what we're putting out there. And once we publish every paper, we also present the data that we have used so that everybody who is interested in reproducing what we have been doing can actually do so themselves and check directly firsthand whether our conclusions are warranted or not. And the way we're doing this is basically not only by making the results publicly available with the data, but we're doing that at the earliest moment possible. So after we do our analysis and we do our quality control checks, then we preprint our work, which means that before we're waiting for some other experts to review the evidence and our conclusions from the data, we actually put the information out there for the world. And you may have heard this, but the number of articles, of scientific articles that have been presented since the beginning of COVID-19, it's immense. And we're daily gathering more and more information from different studies all over the world, also on olfaction and taste in chemosensation. So another one of our goals as a consortium is that we want to be inclusive and collaborative. And so not only in the types of members that we are including in the consortium, we want people to be able to look at what we're doing and perform their own analysis afterwards if they choose to do so. And after that, we have been working on disseminating widely our results in different ways. So in social media posts, with the press, in scientific publications. So we're trying to spread the knowledge about chemosensation and COVID-19, particularly because it has some public health relevance, or at least the data that we're now gathering together that have been independently evaluated by different groups kind of point to a story where smell in particular, but also taste, are particularly important for COVID-19 and for all of us. So what did we learn so far? What have we learned up to this point? So as you can see on the bottom left corner, I put a number or a code that is GCCR 001, and this is the friendly name of our first paper, because we worked on them so much that we kind of needed to call them by their own name to some sort. So the first time we looked at the data was after 10 days of the deployment of the survey, and we had data in 11 languages. And so we looked at, like, in 11 days, we actually got more than 4,000 respondents that reported to have had a COVID-19 diagnosis, either through a lab test that they took or through a diagnosis that was done by a healthcare provider. And so what did we learn? What are the results when we look at the questions in which we asked them, how is your sense of smell during the disease? How is your sense of smell? How was your sense of smell before the disease, or taste? Like, what can you tell us about smell, taste, and chemesthesis? What we learn is that there is a sudden smell loss, but not only that. So the first reports focus only on loss of smell and just ask the questions like, did you lose your sense of smell, yes or no? Which are very interesting to highlight the problem, but they're not going to tell us the degree to which this smell loss is problematic. And so what we tried to do in our survey was actually quantifying on a scale from 0 to 100. Can you tell us how much did you lose your sense of smell? And we saw that people reported a loss before their the beginning of their own illness, and after and during their illness, of almost 80 points, which is huge. So they reported to have decreased pretty much 80% of their olfactory function during the disease. 70% for taste function, and when it comes to trigeminal sensation of chemesthesis in the mouth, so burning, the cooling sensations, what they report is something closer to 40%. So we have, you know, a variation, and of course, different people will have different combinations of these three types of losses. The first thing that we thought, and before looking at the data, was just, well, smell loss, of course, like this could be like what happens in a cold, that your nose is blocked and therefore the odor molecules cannot get to your nose. And this is why you cannot smell. But then we were just, let's ask people, do you have any nasal blockage that you perceive? And people said, well, not really, or not as much as we would expect when we consider like 80% reduction of people's senses of smell. And so this was kind of a wake-up call for us, saying that, oh, COVID may be special in this respect. So we have some effects at the level of the olfactory epithelium that are more reflective of a sensory neuronal aspect, rather than just your nose is blocked and the ear doesn't go up. And the third aspect that was very surprising to us in the beginning is that we have qualitative smell changes when we looked at parosmias and phantosmias. They were kind of rare, around 10% in this initial cohort. And so it is worth noting that our survey was set out to test people that had been sick in the past 2 weeks. So we were really looking at the very early stage of the disease, and people tended to answer on a broader scale. And so we started to see a little more parosmias and phantosmias over time, but consider that these data were collected in April. And so it was quite early into the COVID-19 pandemic. So then we didn't stop at that. Then we looked at more answers. And so we currently have, I believe, something like more than 50,000 responses at our survey in all these 32 languages. And when we select the groups of people that we would want to analyze based on our hypothesis, then we analyzed, as of July, the beginning of July, 16,000 participants. Both, and these people would have either a COVID diagnosis, or they could have other respiratory illnesses that are not COVID related. And so when we contrast these two groups, and we really try to compare how COVID is special when it comes to smell and taste disorders as compared to other illnesses that are known to produce smell and taste disorders, what we see is that smell and taste loss tend to be greater in the COVID group as compared to people that report other respiratory illnesses. And so it confirms this idea of a sudden, abrupt loss of smell. And what we learned, which was very important, is that when we measure smell, and so not just check a box, so yes, I do have some smell loss, but when we ask people to quantify on scales, like how much did they lose, that is the best way to predict COVID status. So when we try to, just by looking at the data, identify whether a person has COVID or had another respiratory illness, the best way to do that is to look at the rating that people gave about their smell during the disease. And we also started looking at olfactory recovery, although we know that our data are kind of in the early side of things. And so we have data like in the first month let's say, after a beginning of recovery. And what we see is that the majority of people, one of the best predictor is actually time since illness onset. And as Thomas was saying before, people do recover their sense of smell, and some others will take longer, at least in our sample, than those 30-40 days. What we are promoting in our last paper, and this is kind of the take-home message, is that we want everybody to know that olfaction and the sense of smell can actually be a very useful way to figure out whether somebody has COVID or not. And first of all, we need to make sure that people didn't have any previous smell or taste disorder, because of course that wouldn't be a fair comparison. But for those who do not have a smell or taste disorder, then asking during a disease when they present themselves to a doctor, like on a scale from 0 to 10, how would you rate your sense of smell? And people that answer 3 or below, and in particular from 2, they have a very high probability of having COVID-19 based on the data on our sample. And this can be particularly useful when we consider that if you think of fever as one of the measures that is currently being used to determine whether people have an ongoing infection, and if that infection is COVID, fever is not being as effective in predicting whether you have COVID or not as compared to asking questions like this. So how is your smell right now that you have some other sorts of symptoms? So the Global Consortium of First Chemosensory Research is still at work, and we're trying to keep analyzing the data that we have while also extending the number of studies that we're proposing. So I put there the website. If you're curious, you can follow us on Twitter and on Facebook. We're very happy to hear from you. And if there's any question, I'm very happy to answer any. Thank you very much again for this opportunity.
Thank you, Valentina. That was excellent. I'd like to, before we go and put the questions to the audience, or take questions from the audience, I've got 2 things that I'd like to ask you about, Thomas and Valentina. One is something that I noticed very much in the Facebook group, and that is that the importance of surveys in bringing us closer to understanding more about COVID-19. Now, when people come into the Facebook group, they want to share. Obviously, that's a very important role of a support group like that, so that people can talk. But they're also very much interested in helping science. And Valentina, I'd like you to just talk about that a little bit and explain to people just how important it is that we translate each individual story into a data point that can then get out there into the research community and be used. And why can't a patient's story, say a paragraph, really not help science at all?
So that's actually a very good question. And especially in a situation like COVID-19, in which we have a novel virus. So we really do not know what we're looking at. Actually, stories are the beginning point, like the point where we started. We'll listen to what people are saying, but then one thing is what is an anecdote, like one person has one experience, and this may not translate exactly into what happens on average. And so we definitely want to listen every single person, but we also need to see on a larger scale, at a group level, what is the what emerges when we pull this data together. And as you have seen, like surveys that are informative, like the one from GCCR, are really using big data. We have 4,000 people, 16,000 people. We're trying to really put together data so that all the noise that our personal lives and personal differences may have kind of are teased apart and let emerge what is the common thread. And this is why we're doing surveys, or we're doing standardized testing. So we ask everybody to take exactly the same test to limit the potential of some other confounders that just to laser focus on what is the information that can be most helpful and can resist the test of science. Of course, then we want to hear the stories, and there's a place for that type of qualitative research, but it's a different type of, it goes at a different speed when it comes to provide the general results. that can be implemented in a public health environment or in a clinical setting. And
Yeah.
so for that, we have other gold standards that we need to meet.
Right.
And survey are the first step towards that. Then we need to have standardized testing with objective methodologies and standardized tests in the lab. So it's, you know, science is slow. That's also frustrating for us, but it's slow and it takes time, but also we want to get to the point where the evidence is as solid as it can be.
Yeah. Thank you. So everyone out there, I do hope that you'll take the surveys. It's so important. And Thomas, I've got another general question for you. I think I've seen this in the Q&A panel, but one that comes up again and again in the Facebook group. People seem to be, so they lose their sense of smell. They start to recover. They're recovering an undistorted sense of smell with important fluctuations that may be over a period of days. I know that there can be obviously fluctuations in the sense of smell in a sort of a daily rhythm, but these are fluctuations which people find extremely distressing. They start to recover a little bit, things are smelling the way they should, and then 2-3 months later, after a period of recovery, suddenly the parosmia sets in. Do you have any idea what might be causing this and where within the olfactory system these problems are occurring?
Yeah, these parosmias are really interesting to observe when you have it yourself. It's not so interesting. It's actually very disturbing. What you say, that's what most patients tell us. Where it comes from, there can be various areas. So can come from the periphery, from the olfactory epithelium up in your nose, so that the coating is not correct. And then when you smell something, for instance, you have a rose odor. Rose normally to work, like to produce a rose perception, would have to activate, let's say, R, O, S, and E receptors. And then as you regrow receptors, you may just regrow the consonants. So you may not have the vowels. And so it's still, when you can perceive rose odor, but it doesn't come out as rose, but it comes out as this. Coffee doesn't come out as coffee, but as kf. So something like that. So it could start in the periphery, that the code is incomplete. And other areas where it could come from is like the processing at the level of the olfactory bulb, for instance. When you look at that, actually in the olfactory bulb, there's like, when you look at people with parosmias and compare them to people without parosmias, then the olfactory bulb in people with parosmias is smaller. So there are a couple of studies showing that. And this may be an indication that the processing is kind of not as good as in people with regular hyposmia. So that could be an indication in that direction. Mm-hmm. And then parosmias could come about by higher order processing, like in the orbitofrontal cortex or in other areas of the brain. So various areas that may be responsible for parosmias. But what we also see repeatedly in our studies, that people have parosmias, that this seems to be a good sign. So people with parosmias, they recover faster and they seem to recover more completely. Of course, they have the symptom, which is not very pleasant, but that's what you see in other, where in post-infectious olfactory loss, the parosmias, normally they are a good sign. They also show that you can perceive odors, so that the system is functioning. It may function in the wrong way, but it's functioning. So that's, I guess, what parosmias. I guess when you look at it this way, it also helps people to live with the parosmia. But it's, as you were saying, it's extremely disturbing for many people. If you always have like a burn smell in your nose, regardless what you perceive or what you eat, or if something is fecal, then it's not nice. So these people are very depressed, and then they just have to hope for that this is sort of going away after a couple of months, which is very likely to happen. Right,
right. And Thomas, just to clarify, what you've just told us right now about parosmia being a good sign, and that it indicates that perhaps ahead there will be a more complete recovery. Are you saying that based on the COVID-19 patients that you've seen recently, or is that drawn from your broader experience of pre-COVID related post-viral loss?
That's strong from pre-COVID
Right.
associated olfactory loss.
Right.
Right now, the observation time is just too short to come up with any of these ideas,
Right.
because it just exists since March or so that we
Yeah.
actually can have some data on these patients.
Yep. Yep. Okay, so I think over to Aidan now. Aidan, do you have any good questions for us?
Yeah, we've got quite a bit here to go through. We've got first one here is, should we change oils and add new ones as we continue training? Will this help the brain and senses to recover?
So Thomas?
There's the evidence there is, or like we call it what is, so like there's some ideas that it would be helpful if you change the odors every 2 months or every 3 months.
Okay, good.
Okay. Is it possible to recover the real smells we felt during the early recovery phase, 3 months after infection, before starting parosmia? Or those smells will be different forever?
Mm.
To me,
Yeah. Thomas, what do you say?
that's a good question. Normally, the parosmias, they resolve, so they tend to go away. But there are some patients, and I think it's a small fraction, where the parosmias they become bigger, but they're always there in the background. So you always have it. You always have this burnt feeling. You're able to smell an orange, but it's sort of tainted by this parosmia smell, like a burnt smell that's always there. So in some patients, it stays on forever, but it tends to become bigger.
Mm-hmm.
Okay. Does it make sense to smell train on things we cannot smell specifically, for example, body odor, or will it improve from essential oils as well?
And I think I'll add to that there are a lot of people who start to smell train and then they are immediately frustrated because as they begin, they can't smell some of the things that they're trying to smell train with. And it's a big ask to, you know, to hope that these people will stick with smell training. So Thomas, what would you have to offer to people who say, you know, is it worthwhile smell training with something that they cannot perceive?
Yes, definitely, that would be good. So they should continue with that because it means stimulation of the olfactory epithelium. That's the idea about it. And then the question was whether you train with certain odors, where this would also sort of affect perception of other odors. And the answer is yes. So that's the entire idea of the smell training. So if you expose yourself to odors, this would generalize, also go to other odors. But then how it will evolve, you know, in the end, you know, what odors you will be able to smell or not, that's we don't know that. So that's up in the air. So some people, of course, when also the question, how good will recovery be after olfactory loss, after an infection of the sense of smell? I mean, Chrissy, you had that. So
Yeah.
you had olfactory loss, and so I guess you can add to that experience.
Yes. I may even have said it in one of these Zoom webinars, but for me, coming back from a bad case of parosmia to a new sort of smellscape is a bit like you emigrate to a new country. And when you get to this new country, you're so homesick. The landscape is different, the water is different, the food is different, nobody speaks the same language. You're very, very unhappy when you get there. But after a while, all these things, these new things, they start to be okay. And now I would say for me, it's been 8 years. I had profound smell loss. I had terrible, terrible parosmia that lasted 2 years. But now I don't notice it anymore. For one or two things intellectually, I know that I still have parosmia for those things, but my enjoyment of food and the environment and in my relationships, that is as good as it ever was. And I really think that when we talk about, and so many people come into the group and say, when is my sense of smell going to be 100% of what it was? Well, they'll say, when will I be cured? And I think that we can't think of smell loss as a disease, smell loss in itself as a disease that you recover from, but rather as an injury. And if you were injured and you had a scar, You wouldn't look at that scar and say, when is this scar going to go away? I want to look exactly like I did before. You become healed, but you're a little bit different. And I think that there's a sort of philosophical adjustment that needs to be made. And that's very, very difficult for people, especially when they are in the earliest, most distressing phases of their smell loss.
I think that's a very nice picture. I mean, we have many patients, they say, oh, I'm perfectly fine, but actually the measured olfactory function is like still in the hypoglycemic range, but they're quite happy with that.
Yeah.
So it also depends where you come from. You know, when you come from basically nothing, when you don't perceive anything, and gradually with time you start to get to learn a few odors, and so you can perceive something, that this can also be quite satisfying. So actually being cured has different levels. So
Yep. Yeah.
So we have a question here from Trevor, who asks Thomas specifically, do we have evidence of what part of the perceptual function has been recovered? For example, is it the ability for simple discrimination between two odors, like the triangle test, or is it mainly the ability to recognize what the odor is? It's a very technical question there.
Yes, I think it goes in all directions. So when you have very low olfactory function, then what first can be seen is that threshold is coming back, so that people can have an increased sensitivity. And next thing then would also be that the discrimination of two odors also is improving, so that you, without knowing what you smell, you can determine this is different from other smells. And then, you know, that's the nicest part of it. Then you can, in the end, you can also identify odors, so you get the full picture. So this would typically be the involvement of olfactory function. Of course, there are some variations in there. Some people experience differently, but generally it would evolve that way. You see it also in aging, the other way around. In older people, they first lose threshold function, so they become less sensitive to odors, but they still keep odor discrimination and odor identification. So then it goes the other way around.
We have a question here for Valentina. We have seen that people who have lost their smell due to COVID can feel the effect from months after having the virus. So surely using anosmia as a way to judge if a person has COVID would be inaccurate.
So what we are trying to ask with that scale is actually two things. So one is that, did you have a previous smell loss? And then we want also to know whether somebody has had COVID already with smell loss. So we're trying to exclude people who already know that they had some sort of smell and taste disorder at a certain point in their life for different reasons. We have ways afterwards to actually measure that specifically with other tests. And so that would be the first step. But let's say that the majority of the population would still be considered normosmic. And so if we have to choose between measuring, fever at the entrance of a building or asking the majority of people whether they can smell something, what we know as of now is that neither of this measurement is perfect, but if we can bet better on the smell part. We have, of course, to define whether somebody can smell in the first place. And so that's why also in the GCCR, we ask questions about people's previous ability to smell. Mm-hmm. So of course, this question cannot just be answered like a fever test right now, as of now, what's your temperature? But we need some extra information to contextualize it. But it's true, after COVID, you can have lasting smell disorders. And so we need to catch those people and separate them from the groups so that we can test the others. And for these people, we have to find, of course, other types of way of testing, but some of them will have already the antibodies because they had the disease before.
Mm-hmm. We have a question for everyone here saying, which patient usually recovers smell faster? The one who has a nerve commitment or the one who has a nasal inflammation, and why?
Thomas, if you want to go, I can give my little bit, but you may know more. So inflammation seems a process that comes and goes more easily and doesn't have like a more important effect and more long-term effect, like a nerve problem issue. So as we see in COVID, the inflammation processes could be at the basis of this abrupt loss of the sense of smell and abrupt recovery as well in at least a group of patients. So that should be, at least a part of the group could have this type of information for, quick types of inflammation. But Thomas, I'll let you more thoroughly answer.
Not necessarily more thoroughly. It's just like, I think the question is difficult because it's typically you don't have that separate. So you have like a nerve injury, it always comes with inflammation, and the other way around. So it goes both ways. And then inflammation, there may also be, don't know what's meant here, it's like chronic rhinosinusitis, like chronic inflammation of the nasal cavity. That's a slightly different issue. So, because then you have a blockage of the nasal cavity, and there you can work wonders with corticosteroids, So at least at some stage of the disorder, you can work wonders with surgery or things like that. So in a way, that's easier to cure. In another way, it's not, because it's like chronic, it comes back, there are relapses. So it's a good question, but the answer is kind of tricky.
And we have one saying here, and this is more related to, perhaps you can bring something in here, Valentina, because of the survey. We have someone asking, is there any significant gender variation in terms of prevalence of anosmia?
So when it comes to our specific data, the majority of our participants were female. And so, but I have to mention that the GCCR has an opt-in bias. So people decide for certain reasons to answer the question. And so the majority of people we see are women. We do not find particularly interesting gender effects, but also we didn't stress like too much the type of analysis because we know that our sample is pretty imbalanced when it comes to COVID. Generally speaking, we find differences. Women tend to perform better at olfactory tests as compared to men, generally speaking. But that is what we see with respect to COVID-19.
I think we have time for one more quick question. I see one here that I know I've asked Thomas about in the past, and it was about, are there any studies which prove the efficiency of acupuncture for smell loss? I know that you told me about a little study that you did, Thomas. Would you maybe recap the result of that?
Yeah, there are a couple of studies out there, and the results are not very clear. There was one study that was done by people in Cologne, and they had quite promising results. And then actually, in the same volume where this was published, there was a paper saying that the statistics were wrong. So it was kind of, that was not so good. There's some papers saying of the literature is actually, I think it's 6 papers or 7, that says there could be an effect of acupuncture. We tried that ourselves, and actually we wanted to find out, we did it like in a group of about 100 people, 50 people treated with sham acupuncture, 50 people treated with real acupuncture. And then basically my intention was to show that acupuncture is not good for anything. So because I'm sort of, I didn't believe in that. But then what we found here was very clearly that acupuncture produced a very nice, significant effect on odor discrimination. So it was really large and was very clearly there in this nicely controlled study. So that's what I can say to you about acupuncture. We're writing the study up, and I don't know how this comes about, how acupuncture should work. It's kind of in a way, it's sort of fitting that acupuncture could do something in odor discrimination, which requires a lot of cognitive function also. So it seems to work less on the periphery, but more like on the central nervous effects, which I don't understand. But it's like the phenomenon seems to be there, and yeah.
And why not? If it makes people feel better, why not? I'm afraid to say that we have reached the end tonight, and I'm going to start my signing off by saying I'm really sorry about what happened tonight with everybody getting in. That was my fault. So let's hope that in 2 weeks, when I am here with Jonas Olofsson from Stockholm, from the University of Stockholm, we'll be talking about what happens to the brain when we smell train. And so I hope you'll be joining us for that. And let's just keep our fingers crossed that there are no more technical glitches. But thank you very much to Valentina Parma for joining us this evening and telling us about giving us the GCCR story. And to Thomas Hummel also, I'd like to thank you very much for being with us tonight. And I'm sure that in the future, it would be great to have you come back again and maybe answer some more questions. So that's it. And Aidan, of course, thank you very much. So we'll see you in 2 weeks, everyone. Thank you for your participation. Good night.
See you later.
Thank you.